Today we are going to start with a warm-up on refreshing your line of symmetry equation. So how do we find that? So remember, when we are working with equations that are in standard form, what we are looking at doing is to take the opposite of b all over 2a. So line of symmetry is x equals opposite of b all over 2a. Well, my opposite of b value here would be a positive 10 all over 2 times a, which is 2. So my value would end up being 10 over 4, okay, which then can reduce to 5 halves, or would be 3.5. So my line of symmetry would be located at x equals 3.5. Our line of symmetry is going to be really helpful today as we are working our way through application problems. At this point in time, your applications with parabolic functions worksheet should be out to you. We are going to go through the problems on this sheet as a group. If I start to go too fast, please, as the teacher or in control of the video, pause it where it is needed so that students can properly adjust. Our objective is to model quadratic equations and to find solutions using your background knowledge of symmetry, vertex, and using the quadratic formula, and maybe even some factoring. This sheet, as I said, should be in front of you. We are going to read through problem number 1, which says, use a graph at the right. Shows that height, h, in feet of a small rocket, t seconds after it launched. The path of the rocket is given by the equation, and it is also shown in the graph to the right. The question is, how long is the rocket in the air? Please pause the video, allow students to answer the 2 questions before moving on. We determine our answers by looking at the takeoff point of our rocket at time 0 and the landing point here at 8 seconds. The path of my rocket is seen here. The highest height that it reaches is at 260. Continuing on with the same problem, we would like to answer questions 3 and 4. We would like to know roughly how high is the rocket after 1 second? How high would the rocket be after 2 seconds? Please pause the video, allow students to use the graph or the equation to find their answers. Notice after 1 second, our rocket is at 100 feet. Okay. At about 2 seconds, we're looking at roughly 190 feet. Notice that the path of my rocket is going up. At this particular instance, it has not turned back to Earth yet, so the rocket is traveling up. Take time to answer 5 and 6. Pause the video, allow students to answer before moving on. At 6 seconds, the rocket is roughly 190 feet. It is on its way back down to Earth. From 0 to 1 second, our rocket has a steeper slope than it does from 3 to 4 seconds. You'll notice, look at how much height is changed in 1 second versus the height change here in 1 second. Right? So we are going faster from 0 to 1 than we are from 3 to 4. Our last question with this graph, take a moment, answer it. Find the exact height of the rocket at 2 seconds, what we would want to do is place 2 within the time of our equation. Doing so allows us to square first, so 16 times 4 plus 128 times 2. Our rocket has a height of 192 feet exactly at 2 seconds of travel. We next have a blank graph grid for us to look at the path of a ball that's being thrown in the air. They give us the equation negative t squared plus 8t. We would like to graph the equation from 0 to 8. A couple options of what we could do is we could make a table of time and height, and we could put in 0, 1, 2, 3, and so on all the way until 8, graphing each location. Doing so, we would have the exact locations to graph. Please, students, take time to fill out your table, find all of your proper measurements, and then please determine what is the maximum height the ball will reach, and how long is the ball above 7 meters. Notice the maximum height which the ball will reach will be 16 feet. How long will it be above 7 meters? Excuse me. We are talking in meters, so it's not 16 feet, it would be 16 meters. When we're talking about above 16 meters, we are 7 meters, we are looking at this height here. So how many seconds is the ball above this line? The ball would be above that line for a total of 6 seconds. At this point in time, flip your note sheet over. As we are working with quadratic word problems, things to keep in mind is that t is time, is represented typically by our x-axis. H or d refers to height and distance, and that is represented on our y-axis. So when we think about a graph, time is on our x-axis,